This upside down triangle is a graphic that I created to help you visualize better what's happening with orbital filling. In other words, the order of orbital filling. We've already talked about the rules from Aufbau, Pauli, and Hund, and now we're going to show how this graphic relates to this graphic of the orbital filling diagram, and also relating it back to here, which is an overall graphic of how things are laid out with the different energy sublevels. The sublevels would be indicated by these letters and numbers. The principal energy levels are indicated on this chart by this. The row number corresponds roughly to the principal energy level number. And so we got 1, 2, 3, 4, 5, 6, 7 rows on the periodic chart, which correspond to the 7 principal energy levels. And we are going to see how to use this chart, and this chart to extend. When I say extend, I mean this chart will only take us up to the 4p and will allow us to do all of the elements, the orbital filling diagram and electron configurations for all elements up to number 36, krypton. And as we go forward here to this graphic, this doesn't let us go very far because it only goes up to the 4th principal energy level. And so to do the rest of the chart, we are going to need to look at this graphic as well. And we'll just kind of knit it all together. To help my classes do this, I started with this upside down triangle and gave an assignment to actually extend this up to the 7th principal energy level and see how the sublevels correspond within the principal energy levels as we go up. Now let's look at this, and I'm going to draw a further representation of the next principal energy level. So I'm going to choose to draw this straight up rather than do flaring out, because this doesn't really go any further. And I'm going to make a row here for a representation of the 5th principal energy level. Now before we fill this in, and let's go ahead and draw our lines also to bring everything up to this level. Instead of going on the diagonal as we did down below, we're going to go straight up now, as just kind of a way to emphasize that every principal energy level does not carry the F's and the D's as we continue up on this triangle. To get a feel for that, let's go to this graphic and let's see how that works. If you'll notice, we have the 1s. That includes the electrons that would be filled in the 1s sublevel of the 1st principal energy level. And if we look at hydrogen, it has only 1 electron in the 1s sublevel. And if we go over to helium, it has 2 electrons in the 1s sublevel. So let's go on down now to the 2nd principal energy level and see what we have here. And if we go back to this graphic, you can see I've just represented with hydrogen and then helium the electrons that would be in the 1s sublevel of the 1st principal energy level. Getting used to these terms is a little difficult, so I'm repeating this over and over again. Now, going back to this graphic, let's see here. We've got principal energy level 2, and we had the 1s, the 2s sublevel, which accounts for electrons that are present in the lithium and beryllium atoms. And now we go across over the chasm of the transition elements, which are down in here. These are all the D block. And we're going now over to the 2p, where we have 1, 2, 3, 4, 5, 6 additional electrons as we go from boron on up to neon. And this will complete the second principal energy level because you don't see the 2 indication anywhere else on the chart. As we look all the way down and even down to the F, we see that there is nothing. So let's go back now and see this chart, and what did we just represent? The second principal energy level, the 2s, and the 2p. Now we need to talk about what this chart actually stands for. 1s stands for the second, in the second principal energy level, stands for the sublevel of S in the second principal energy level, just like this referred to the sublevel of S in the first principal energy level. Now, as we go over to the P's, we're going to see that there are several orbitals. These letters in the S refer to the sublevel and the single s orbital. Each orbital can carry 2 electrons. Now this s is in the second principal energy level, also refers to the s sublevel as well as the s orbital, which is the only orbital that is in any of the s sublevels, no matter which principal energy level we go to. And now in the P, we start to see that there's more than one orbital within this sublevel. There are now 1, 2, 3 p orbitals in the p sublevel on the second principal energy level. Now let's go up to this chart and let's do all of the electrons that I just represented. We have the 1s with 1, 2 electrons. We have the 2s with 2 electrons, and the p, as you recall from the Pauli exclusion principle, in which we have more than one orbital within a sublevel, we have to give 1 electron to each, and they also, when we get the, 1 electron to each using the Hund's rule. Hund's rule says that everybody has to get 1 within a sublevel. Every orbital, there we go, got it out. Every orbital has to get 1 before any of them can get 2. And when the second electron goes into an orbital, it has to have an opposite spin according to the Pauli principle. And then we have just completed what I have just written on or what I've just done in stepping you through the second principal energy level. Now let's go to the third principal energy level, and you'll see we add another sublevel. This is the D sublevel, which has how many orbitals? What do you think? That's right, it is 5. And within each of those orbitals, how many electrons could we possibly have? 2 maximum. That is correct. So let's look. We see have only 1s again. So 1s orbital in the 1s sublevel. 1s, so yeah. And we're in the third principal energy level. So this is actually the 3s. And the 3s is the sublevel, and s is the only orbital that we have in the 3s sublevel. Now we have the 3p sublevel, and we have 3p orbitals within the 3p sublevel. And now we're looking at the D in the third principal energy level, so we call it the 3D sublevel, and we have 1, 2, 3, 4, 5 orbitals. Now, I'm going to fill up that 3p sublevel in our little diagram over here. And we'll also do the 3s. So we've got 3s with 2, and we have 1, 2, 3, 4, 5, 6. Now, when we filled that up, we just got to the element argon. Argon is element number 18, and you'll see we have 2, 4, 6, 8, 10, 12, 14, 16, 18. We have 18 electrons. And now let's go back over here and see what just happened. We have the principal energy level 3 on this chart represented, and we had a 3p and a 3s. Now, we also have a 3d. Where is that? Can you see it on this chart? Good. Right down here, the 3d. Now, let's start breaking this into blocks. I'm going to use a different color for each what we call block. And we'll start with the S block. I'm going to outline that in blue. The S block, it refers to all the elements in the first two columns of the periodic chart, and it also includes helium, which is over here. You'll notice there's an S in that box. So that is our S block. Now let's do in green, let's do the P block, because that's the next one that came up, right? And here we have what is called the P block. And if you have one of these charts, it would be a good idea for you to label it like I'm doing right now. And let's refer to this guy. This is our S block. And whenever we're looking for S orbitals or S filling, we would look in the S block. When we look for P orbitals or P filling, and let's also refer to this as the S block. It's part of the S block. Okay, that's helium. And now we've looked at and seen where all the P's are, all P orbitals and all P filling occurs as we go across the table in the P block, no matter what principal energy level we're in. And now let's go to the transition elements, which include everything that we call the D block. And the D block would be here, and this is where we go to find anything that's happening with D orbitals or D sublevels. And finally, the last block is down here, which is technically actually part of the D block, but we always refer to it separately, differently. And this guy is called our F block. And you'll notice the blocks are always determined by the, not a very good B, there we go, sort of okay. So now we've identified all the different blocks, and the reason I said the F block is part of the D block is because you'll see these arrows right here. I'll do this in blue so you can see it more easily. There we go. See, this whole row that I just went down to, the first row in the F block, which is referred to as the lanthanide series, okay, this guy fits right here. It's actually sandwiched in there. And the reason that we don't have it there is because all of the S and P electron blocks are elements that we call representative elements. And as we go vertical within a block, all elements within that block have very, very similar chemical characteristics when they react with other elements, that is. Okay? And here we have the second part of the F block, and we refer to this as the actinide series. And the actinide series, oops, let's put that down, pick it back up now for it. now you see we have the actinide series here. And where that fits in is right here after actinium on row 7, which is the last line of the D block. Now, I'm also going to write in for you, because on my chart we don't have this, but these elements either are identified already, and we've got one right here, and I'm not going to give you the name of that right now, but that element has been discovered, kind of like on Mendeleev's chart. When the way it was laid out, we could discover other elements. Now we're ready to rock and roll. Let's go back here now and see what's happening on principal energy level 5. For that, we are actually, or no, let's do 3 and 4 first. For 3, let's go ahead and do the completion of this one. Before we get to the 3D, we have to go to the 4s. They just fill this way. And with these, they act just like the P's. We have to get 1 per orbital before we do 2 per orbital. And the spins are opposite according to the Pauli exclusion principle. Now you can see real quick here on this little chart, I'm going to run out of space. And here we go with the 4P, and after the 4P, we are done with this chart. So you can't really go any further. But if we go back here and we look at the 4th level, you'll notice that we have F's to deal with. And I'm referring to these guys right here. Okay? And they're not going to show up until they hit in their proper order. And the proper order is going to be given to you by this chart as you go from top to bottom and left to right. You can depend on things filling in the order that you see here. Now in the D block, there's going to be some exceptions, which in my course I don't even deal with. I just treat it as if it were 100% regular. So I'll have technically some errors when I do the configurations this way, but I find it's the technicality of that is not worth the confusion that it causes my students. So let's see. We did the 4S, we did the 4P, and now we've done the 3D also. So to finish off principal energy level 4, I have to go right here, yes? And that's where I'm going to have the next part of my electron configurations. So let's go ahead and look at what's going to happen on 5. On 5, okay, principal energy level 5, and on 4, I'm going to have my 4Fs down here, my 4Ds are here, and the 4F is right down here. And so we don't get into the 4F until we're actually down on row 6. And so we have to be sure that we understand where we are and how things are going to progress. So I'm going to do an electron configuration based on this table alone. And we'll put another little slide in here so that we can actually do that. And I'll use the noble gas configurations to make this a little bit easier and less time consuming. So here we go. We're going to hit the noble gas. Let's start at argon. And so as we go over here, we're going to do argon like this in a bracket. And this is considered a noble gas, and it will start our noble gas configuration. And so as we go past argon, what are we going to run into? We're going to see, after argon, we're going to run into the 4s. And the 4s will, of course, be included on this chart right here. So we'll go across. We can't use this for orbital filling, but we can use it to visualize the principal energy levels only. All right, now let's go back, and now let's look at this. And after argon, we're going to see a 4s at potassium on the fourth principal energy level. So we're going to do 4s, a 3d, and a 4p. And let's see how that looks. 4s. 4s is going to have 2 electrons. The 3d is going to have a total of 10 if they're full. And then the 4p is going to be right over here. The 4p will actually be a total of 6. And then we have to go on to the next level. So the next level, and I'm talking about rows on the periodic chart. We go to row 5, and that principal energy level 5 starts right here. And we'll have a 5s, a 4d, and then a 5p. Now watch as I do this, the rest of the configuration. Okay, we have a 5, oops, let's start with 5s, yes. Back here, one more. Okay, 5s. After the 5s comes, notice, whoops, we got to put 2 there, comes the 4d. The d's will always have a total of 10 if they are full. And then we're going to have the 5p after that. And that'll have a total of 6. And now I've got my electron configuration all the way over to, we're on row 5. We just finished on up to xenon. Okay, now as we go to the 6th principal energy level on this chart, the filling begins like this. We're going to have a 6s, then we're going to have a 4f, okay, the 4f, and then we'll have the 5d and the 6p. So notice the S and the P's on principal energy level 5 will be from principal energy level 5, or considered as part of principal energy level 5. And then the next thing that we're going to see is that the F4F, this guy down here, is going to fill after the 6S, and then we'll have the 5D and the 6P. Okay, so let's go back to here, and again, we're on row 6. So principal energy level 6, we have the 6S that fills first. Then we go down to a 4P, I'm sorry, a 4F. See what happens here? We hit 6S, then we go down to a 4F, which we're going down here with, and the 4F is going to have a total of 14 when it's full, and then we'll have the D's, which are on principal energy level 5, and they're going to fill with a total of 10. And I'm going to have to use the second row for this. And the last thing that's going to fill on that principal energy level, as we look at it on the chart, is going to be the 6p, which will get a total of 6 electrons. And at this point in time, my configuration now represents the full 6p, which would be radon Rn. Okay? And now you can see how this thing can be used to do all of the elements on down to the little X that I have in the, here, I didn't do this yet, let's do it now, in the 7p block, or 7p row. It's principal energy level 7 in the S block. I hope that helps you a little bit. Let's go back now and kind of summarize what we did as we went across. And if you have a copy of the periodic chart that I was using, that I made up, you can go ahead and relate it to this. As I filled in these guys right here, I was going across the periodic chart, strictly going across the periodic chart, and filling in the total possible electrons in each of those. And then as I went across principal energy level 5, things got a little different. Okay? Well, not all that different. But look here. This 3, the 3D is one less than the 4. At least the principal energy level. See, this guy represents the principal energy level. And this guy represents the orbitals, or the sublevel of orbitals, that we have in the 3D. Okay, and now as we go to 5, we go from 5 down to 4 again. This follows the same pattern as we had with the principal energy level 4. The 4D, C4 is one less than the 5. Now, when we got to principal energy level 6 and we went across that, and for that I'm going to leave my box open over here because it continues down here, we had 6S followed by the 4F. See the 6S followed by the 4F, which is 2 levels down now. And then the 5D, and then back up to 6. And that's just following straight across the chart. And it helps us to get the orientation for how this guy works. I hope this has helped you and not confused you in any way. And as I've gone through talking about all this stuff, all the different terms that we use in referring to electron configurations are going to be ringing in your ears and hopefully help you really understand this stuff. Thank you for watching, and I hope this has helped.